Hello, my name is Kushini, and in this presentation, I will be exploring one of the universe's most favorable characteristics, and that is its tendency to repeat patterns. With that being said, the universe holds much randomness in its folds, which, upon initial glance, may seem like chaotic behavior, but if studied further, may seem like a carefully organized set of chaos. Thus, in this presentation, some many examples of natural patterns will be analyzed, which will later be used to form a general consensus. From subatomic particles to stars and yonder, a shape whose dimensions take a much favorable tenor is the spherical shape. Firstly, spherical cosmological bodies form due to the gravitational forces inside the object, pulling its molecules inward towards the center of gravity, while the surface tension keeps it intact. Secondly, a bubble forms a spherical shape due to the competition between pressure and surface tension, which minimizes the surface area. In this case, one that surrounds a prescribed volume of air. The surface tension is balanced by the air from the inside pushing the bubble out. These occurrences are examples of conservation of angular momentum. Some subatomic particles present themselves in a round nature because they are produced by the solar's quarks, thus being under influence by a more minuscule centripetal force compared to other subatomic particles. In nature, some animals create spherical nests with the purpose of minimizing the surface area, thus minimizing the quantity of materials being used, while at the same time maximizing the internal volume of the nest to lessen the amount of heat that is being lost. Certain objects in nature require symmetry to operate. Flowers of a symmetrical organization produce nectar in quality and quantity due to the plant individuals of superior phenotypic and/or genetic quality having a superior ability to produce both a stable phenotype and large amounts of pollinator rewards. Einstein was able to enrich his concept of spacetime through the inspiration of symmetry, which in turn became responsible for the advancement of quantum mechanics. Einstein's theory of relativity was based on the principle of equivalence. Furthermore, in the development of the periodic table, the discovery of groups 2, 8, and 18 were based solely off patterns such that they followed directly from the rotational symmetry of the Coulomb force. Not only was symmetry used to find these groups, but it was used to predict the existence of the antiparticle originally predicted by Paul Dirac. Symmetry has always been an integrated part of nature because the universe is always trying to find the most efficient solution it can, and does so by duplicating itself. Of the three shapes that are identically similar in size and shape such that they fill out an area leaving no space, hexagons are the most efficient shape. This provides great reason as to why honeycombs are made of hexagons, because they provide the same amount of area with the minimal amount of perimeter or wax used. The use of this shape concisely compacts the honeycomb, leaving the object with no spaces or wasted wax. It should be stated that the honeycomb is originally created in circular units, which then reach hexagonal shape due to the heat from the bee's body softening the wax. The reason for hexagonal shape is due to the softened wax creeping along the network between the holes. The wax hardens in the most energetically favorable configuration, producing a hexagonal pattern. The hexagonal structure allows the surface tension to achieve mechanic stability due to its pull in each direction. Basaltic rocks are formed as the lava from volcanic eruptions cools as it reaches the surface, resulting in a great amount of pressure formed as it solidifies. Ultimately, this pressure causes cracks, which forms in the shape of a hexagon, due to the angle that releases the most tension being 120 degrees. Furthermore, snowflakes form due to the freezing of water molecules. In this process of water freezing, known as crystallization, the water molecules align themselves to maximize attractive forces and minimize repulsive ones. This mathematical model explains the patterns that can be seen in nature. Suppose there are two cells of identical nature with an embryo that, when in contact with two chemicals, can activate or inhibit some sort of reaction in the cell. Thierry named these chemicals morphogens. Upon having contact with the embryo and diffusing through them, the morphogens will cause a transformation about the cells around them, which in result would produce a range of patterns, whether they be spots, stripes, spirals, hexagons, and whorls. Furthermore, the rate of how the morphogens change influences how the patterns form. In recent studies, it is found that the number of digits in a paw falls under the category of stripes. Firstly, as the paw forms, it begins as a continuous collection of tissues. Two genes control the making of morphogens. This chemical forms the making of digits, while another gene produces morphogens that are responsible for cell depletion. This process was responsible for creating the number of digits in a paw. Analyzing this example, it is seen how nature takes one model and applies it to many of its subjects. The logistic map is a mapping of chaos propagated by Robert May to study the growth of a generation of biological species. This map is a recursive function that maps the growth of a species in a given year, which is then inputted into the equation for the following year. If the growth rate is higher than 1 and keeps increasing, then until a certain point the percentage of the population will increase steadily until after said point the graph splits into two. Increasing further, the previous two oscillations will again split into two. This pattern will keep occurring as the previous two branches become 4, then 18, then 16, until it stops at r equals 4. This is known as the bifurcation diagram. Many examples are listed below, involving thermodynamics, some aspects of biology, and just common observation. Thus, these examples take one simple equation and follow it in a way where, despite the many unrelated examples, these natural observations obey this one model. Lastly, the Fibonacci sequence is a very common existence in nature, which holds a definitive value despite its simplicity. To expand on this, the Fibonacci sequence is a mathematical sequence that takes the sum of the previous two numbers and continues onwards. The squares of these numbers can be taken, placed beside each other in such a manner where they articulate a spiral pattern called the golden spiral. Multiple examples are listed beside. It can be concluded saying that there are many sources which put forth the common thesis, being that nature has many simple codes which a large quantity of its creations follow. It is efficient and accomplishes its goal with what it has. The words such as optimize, minimize, maximize, economize were repeated words. If humans were to be any better, we could surely learn from what nature has to offer, and so, as we have come from nature, we should return to it once more. However, with the life we have in between, we should cherish it with the much given love it gives to us. Thank you for your valuable time, and I wish you a wonderful day.